Let me give a proof of the following divisibility test by 17. The test says that if you have a number in base 10, then what you can do is break off the number that is just the units digit and the tenths digit, subtract twice the rest of the number, and then if that number is divisible by 17, the original number is divisible by 17. The two basic ingredients of the proof are the following. First of all, a number is divisible by 17 if and only if the number is congruent to 0 modulo 17. And second, 102 is 6 times 17. That means that 102 is a multiple of 17, so it is 0 modulo 17, and that means that 100 is congruent to minus 2 modulo 17. Now, if I write my number in base 10, by the definition of base 10, that means that this number is equal to the number that is just the units and tenths digit plus 100 times the number that would be starting with the hundredths digit. That's what the expression here means. And then if I replace equality by congruences, 100 is congruent to minus 2, so I can replace 100 by minus 2. So that means that n is congruent to the number that I claimed before, where I just have the d1, d0 minus 2 times the number that starts with the hundredths digit, congruent modulo 17. So finally, what we get is that n will be divisible by 17, even only if n is 0 modulo 17, but since n is congruent to this number modulo 17, will be even only if that number is 0 modulo 17. If you bring this to the other side, n will be divisible by 17, even only if this number here is 0 modulo 17, and this is 0 modulo 17, even only if this number is divisible by 17. So n is divisible by 17, even only if this number is divisible by 17, which is what the theorem says.